Part 2, design the solution of oil and gas data warehouse 101 here on this, recording this here on this gorgeous July 16th, 2024. Time stands a little past 2 p.m., so we will go ahead and kick this off. As mentioned, we covered part 1 last week, so if you hadn't had a chance to listen to part 1 and you're just diving into part 2, please feel free. You'll be able to register, go back and watch part 1. It'll be great to kind of get an idea of how we set part 2 up. And then obviously next Tuesday, we're going to have the infamous part 3 where we actually get our hands dirty a little bit and build a report. But today, what we're going to be talking about specifically is the idea of designing the solution that you're going to use to actually hopefully pull off your data warehouse. So that's kind of what today's is going to be focused on. For those of you who didn't join us in part 1, quick reintroduction here. I am Michael Tanner. I work here at Sandstone Group. We do a variety of stuff, and just really excited to be on this webinar. We also got 2 other people. I'll let them introduce themselves.
Yeah, Paul Graham, just experience building data products and specifically data warehouses, also with Sandstone, and also excited to be here.
Hey everybody, I'm Casey Harrison.
And last but certainly not least, we got Casey.
Casey, yes.
I think she's frozen, but Casey is she's the most important one in this webinar. She's the a senior manager over at W Engineering in their solutions engineering department. We left off with this idea of a data silo. And if you work in oil and gas, you're most likely dealing with this problem, which is that your data is currently siloed in multiple different platforms, and it's siloed in multiple different systems. If you work in land, generally you've got your land software where, great, you can do everything from a land perspective, but if all of a sudden you need to layer in your accounting data, well, now you have to cross-collaborate at some point. If you work in production or operations, your data is generally siloed, and if you all of a sudden want to see production versus forecast, well, now we've got to go ahead and do a bunch of cross-referencing and consolidation from specific software. So it can be intense, and generally you end up with some ever-growing Excel file. If you're like me, when I was working in operators, the data warehouse ended up being Excel. It's not a bad thing, but can't leave that. So we kind of walked through again in part 1, well, scoping the problem, what the problem is, and how to figure out exactly what solution you need. And now what we're going to do is actually go ahead and attempt to design the solution. And so I gave that analogy specifically of you've got a Ferrari with a lawnmower engine that only looks good until you go to actually use it, and then you realize it stinks. And what you actually rather have is a van with a jet engine. And so specifically, this is your van with the jet engine. It can be confusing to look at because data warehouse can, in your mind, be a little bit like, oh, what is that? But really, it's the jet engine that lays underneath everything and is really the actual solution that you're going to need. So simply what a data warehouse is, it's a central place where you can connect all of your different source data points, whether it's land, accounting, production, any type of operational databases. You use a specific ETL process, which we'll cover in this, and throw it into a data warehouse. That data warehouse can be a variety of solutions. You saw a few of them listed in the polls, but they can really be anything. And then what happens is your BI tool, which we will definitely talk about, the infamous Power BI versus Spotfire that seems to rage. Everybody wants to know which one you prefer. Well, whatever your solution is, you can layer that on top of your data warehouse and can specifically start building your reports. And now you can start cross-collaborating between your systems because you have everything in one place. And as you'll see in part 3, having everything in one place makes it very easy to say, I need to look at division orders and I need to layer in my land information with my budget information. Well, those come from 2 different systems, but we've done the hard part of putting them in a system. So really throughout this whole data warehouse process, and if I say anything for those listening right now, if I say anything that, I'm going to try to speak in non-tech terms. Luckily, I'm not like a hardcore tech guy, so I tend to be able to explain things a little bit more low level. But if I say anything that's confusing, feel free to use the chat. We'll definitely, as Harrison mentioned, answer questions in real time. You've got 3 key decision points that really, when it's talking to you about building out your data warehouse. One, you've got to choose a database. if we go back to slide 1, that internal part right here, that data warehouse, well, that is just a fancy word for a bunch of databases that you've consolidated into one system. So when I say data warehouse, think of it as just a group of databases, but that all play nicely with each other. So you've got a decision to make. Do you want to use SQL Server? Do you want to use AWS, Azure, Databricks? The list isn't infinite, but it definitely is not just Azure versus AWS. And so figuring out what database you want to use is one of your key decision points. Your next is your ETL process. And this can, like everything, there's 1,000 ways to solve a problem. There are ETL packages that you can purchase, like Azure Data Factory. Databricks has a built-in ETL process that you can use, or the good old-fashioned scripting and build your own ETL process using Python, Rust, C++. Again, multiple different ways to do it, but figuring out what ETL process works for you. And then finally, as I sort of pre-warned you, your BI tool. You've got a lot of different choices. Your big ones are Power BI and Spotfire. You can use Excel. And that's one of the things as we talk at the end about a W-specific product data view that's really awesome, is actually allows you to use Excel. And then a fourth one that's kind of used. I've seen it a little bit, not so much in oil and gas. Paul's seen it a lot in other industries, which is specifically Tableau. But we're not going to spend much time talking about it because it's very rarely used in the oil and gas business. So let's go ahead, and I want to start with your database. And really, in deciding on what you want to use for a database, the first question that comes up is on-prem versus cloud. And basically, the difference between on-premises and on the cloud is, in reality, the cloud is on-premises. It's just a matter of who owns the governance. The cloud you can think of as a data center that's sitting somewhere in Virginia. If you use AWS, you're generally hooked up to their East or Western Virginia data set. If you're using on-prem, it's probably either sitting in your office somewhere, or it's sitting in a local co-working space or co-location space somewhere. But really, the debate versus on-premises versus cloud comes down to 3 different things. One, it really depends on what your current IT department prefers to use. If you are at a larger company and you have whether it's an internal or external IT department, what they're really going to want to know, they may have specific security requirements that say, hey, no, you have to use us for your data infrastructure. Or, hey, we need to be the ones that manage your cloud instance. And so things can look a little bit different. The other thing that your IT department's going to want to know is who's going to own the deployment. If you go with an on-premises deployment, well, your IT team is the one that has to maintain the uptime. And, if you've dabbled at all with any cloud databases, what's the one thing that they talk about all the time? Well, we have 99.9% uptime. Why? Well, because databases do go down. I've used on-prem. I've managed my own on-prem databases before, mainly for fun, just to see how they work. And trust me, you don't get 100% uptime, especially if you're living in Houston right now. When the power goes out, well, your database goes down. So there's a variety of different things that specifically your IT department is going to want to know. And then they're also going to want to know is who owns the governance and the ongoing maintenance. This sort of rolls into deployment. In terms of outsourcing, I do think that your whether or not your IT team is internal or external, they may or may not specifically have some rules or say, hey, we have experience deploying and maintaining servers, or hey, we don't. We prefer you to go with a vendor that we use. Or they're down to go to the cloud. One of the things that I've seen in my kind of, now that I'm the consulting side of the business, smaller companies generally have less data governance or security practices than larger companies. And now we can argue all day whether or not that's good or bad. So generally, your smaller companies tend to be, it's a little bit easier for them to deploy cloud solutions because they can just go sign up for a cloud database right then and there and get going on AWS. Whether when you get to a larger company, they're going to have a little bit more stricter data governance. They're going to probably, your IT team is probably going to want to own that deployment. So depending on exactly your setup is kind of going to guide that. So first thing is kind of just defer to your IT department. The next thing to consider versus on-premises or cloud is, what is your budget? Newsflash, both cost money. You're not going to get an IT infrastructure or a database infrastructure that doesn't cost. But and this is specific. I'm going to bring in Paul here because this was when we were prepping these slides. He brought this up. Hey, do you like surprises? Because from a cloud database side, you get charged in a variety of ways. AWS and Azure, Databricks, they all charge you on different levels. And really the key with going with a cloud service is fully understanding exactly how much this instance is going to cost. Paul, what's the big thing when you're going with to worry about when you're talking about budgeting for a cloud instance?
Yeah, certainly. Can you hear me, Mike? Okay, cool.
I got you.
All right, Paul, I hope you can too. Thanks for letting me know. So the specific instance company that I was at during COVID, we were looking at, shaving costs, right? And part of it was then to say, well, let's look at our database, right? Like that's a, continuous ongoing cost. And what we found was that we were spending about $20,000 a month on just housing the database, right? And so then it brings up a conversation of, do we look to consolidate that? Do we look to maintain that? Do we look to, transition that? What's that timeline, that cost, that effort, the human capital that's needed to then offset it? All these sort of things that Michael really talked about. And so as you're going down this path of, which one, there's kind of the unknown to say like how big would your database get, and then planning based on that. Similar to my experience in terms of like real estate, you don't just say, oh, hey, here's the returns and let's just straight line it for the next 10 years. It's to say, hey, like, how is this going to grow and how is that then going to impact in the future? If that sounds, really too complicated, on-prem would really probably be the best, method to go about it, because there's different ongoing operating costs. But fundamentally,
on-prem, not to cut in, on-prem is a static cost because generally you buy a certain size of server, you buy a certain amount of cores, whether it's internal or at a co-working space. Whereas, as you mentioned, on a cloud, it allows you to scale on an ongoing basis. But as you scale, your price point goes up, and it's really matching where do you think your end goal is going to be with where you are now.
Yeah, and so one thing that would be imperative to take away that you wouldn't necessarily get from reading an article online is two things. One, what is your culture? Because I've often found companies that really want tight-knit control are probably going to be on-premise, right? You maybe think of a synonym for control, right? But to say that, that they really want access, tangibility, they don't want other people to, have all those sort of things, right? They just kind of operate in that way. Not to say you have to be in that way, but I'm just saying there is some culture piece to it as well. The other thing is going to be, and I admire accountants for this, because every single month, what do? They balance the books. Companies that I've been in and instituted Scrum, Agile type methodologies, which is just how you go about like releasing software, is then to say you're building in intentional retrospective data cleaning type activities. So what does that mean? Just like an accountant cleans their books every month, right, to reconcile, and every 6 months to go back and then also help for finance for pro forma. You would do the same thing with your data, right? Junk in gets junk out, right? And so oftentimes I found that technology leaders and individuals who are actually pushing the buttons don't set aside dedicated time to understand what their database is today, what it's growing into, and cleaning it as well. Because fundamentally, when you're at the management executive type level and you're making decisions off that, it's not, again, just the data that's there. It's the clean data that really gives the insightful pieces as well as the context around that data. Maybe you don't have the context of data, but you have that data. That then, as an executive, would be to say, hey, like, how do we understand that? How do we get more of that? Things like that. So I'll avoid kind of going down that soapbox, but again, really imperative to recognize there's a culture aspect, but also instituting, just like you have, bug reviews and reducing tech debt, you should also have data warehouse cleanings as well, which most people don't talk about because it is uncomfortable. Everyone wants to do the spring cleaning, but few rarely do. So definitely keep that in mind for whatever sort of solution you go down.
Yeah, absolutely. And then the final is level of effort. We talked a lot in the first part about time to value. Level of effort can be considered the same thing. It's really easy to stand up a cloud database. You can do it in 5 minutes. We could spend the entire call here and spin up multiple databases on multiple different systems, whether it's Azure, AWS, or whatever. On premises is going to be a little different. You're going to need to know somebody how's the deploy. You're going to, do you need to buy servers? Do you need to go to a co-location space? What does your IT team have? But you may be able to easily more forecast exactly what your costs are going to be on an ongoing basis. So depending on what the level of effort and preferred you want, all three of those goes into the decision on premises versus cloud. That key point I say up at the top, does it matter? It really doesn't. Both can accomplish the solutions. It just, again, is fitting and custom fitting a solution to whatever your specific needs are.
Yeah, and it also just echoes what we talked about in the first session in terms of circles, right? You having those conversations and those detail points will then help you pick the best solution.
Yeah. The next kind of part of the entire data warehouse problem is the design. And from a design standpoint, there really is no right or wrong answer. You can have 25 different databases with subtables underneath them. You can have one master database with 400 tables underneath. However you want to design it, there's no right or wrong answer. Generally, what you see finance has their own database, operations has their own database, land has their own database, and all of those different databases underneath them have different tables. But from a design standpoint, because remember what we're doing, we're connecting to outside data sources, we're bringing them in, we're creating and transforming them, and then putting them in a place that makes it really easy for a user to create a report. This is most commonly called what we would call medallion architecture. And if you work in data, you'll hear this a lot. If you haven't worked in data, this may or may not be familiar to you, but really all medallion architecture is a way to design stages so that you move from low data quality to high data quality. And generally it's called bronze, silver, and gold. You can kind of see that chart here where you're bringing in all your raw data. You're bringing in that raw production data. You're bringing in your raw, reserves data, bringing in that raw ERP or transaction level data, and you land it as is in one specific spot. And maybe it's multiple specific spots because you have multiple different databases lined up for that. But all it is it's the raw data. And this is both structured and unstructured data. And that's the key. If you're talking about, ERP data, a lot of it is easy in rows and columns. It's why most ERP systems on the underlying use SQL Server or use a more classical SQL style design. And that's why if you're listening and you're an accountant, you've probably at some point stumbled upon SQL because it's a really easy way to do rows and columns. If you work in production, for example, and you're diving into SCADA data, well, that's more what we would call, as you can see on the chart here, that's streaming data, but that's unstructured data. It's data that may or may not be specifically on time series data. It may or may not specifically be in the same order every time. It may not, it could be time series, but those time series intervals might be different. So basically that bronze level is set up to just bring in all of the data in its format that it comes in, both unstructured and structured. Then as you move from bronze to silver, this is where, if you're talking about an ETL process, which we'll get into, extract, transform, load, we've extracted the data, we've loaded it into our bronze level database. Then as we move from bronze to silver, we're now transforming the data a little bit. We're now applying we're applying some logic. We're applying and defining a structure. We're figuring out what the final schema needs to be in order to actually create some of our business level reports. And we're modifying the data to fit that. And this goes back to when I talked about ETL. There's multiple ways to do this. Some specific databases have processes built in to actually transform the data for you. You can use raw scripting. You can write Python. You can write some Rust. You can write C++ and do some of this stuff automatically. However you choose to go about it and how comfortable you feel going about it doesn't matter. The point is you're going and taking and improving that data quality, moving it from kind of its raw form into something that's a lot more user-friendly. But really where the magic happens is going from silver to gold. So a lot of people say, well, I just need to get all of my data cleaned and in nice rows and columns, getting my individual data lined up. Well, that's 90% of the step. But really, in order for a user to easily be able to build reports, the data should, as I say, the report should build itself. If your database is designed correctly, your report should really build itself. What does that mean? If you're a Power BI user or a Spotfire user, that means you have to spend very little time creating your own custom measures, very little time creating your own columns, because the more you have to massage the data on the report side, the farther and farther and the less data quality, the farther we actually move away from data quality, and the governance around the final data actually leaves. If you're finding out that, every time you build a report, you have to do some custom transformations because the way the data has landed in its final resting place isn't quite what you need. Well, that's technically you're looking at a silver level database, and those transformations you're making within your BI tool are actually the gold level. And that's totally fine to do that, but understand you're now taking a step down on that kind of data governance or data quality standpoint. So going from silver to gold is another transformation step that takes that data and transforms it into really what we call analytics ready. Because at the end of the day, what am I here to do? What is Paul here to do? What is Casey here to do? We're an analyst. We've got to get the job done, and we have to be able to make decisions off the data. If I'm spending more of my time creating that report than I am sitting there and analyzing the report, something's gone horribly wrong. So the difference between silver and gold is taking that cleaned data, according to the chart, filtered, clean, and augmented data, and really getting it into that analytics ready format, which when we get to the end here and Casey talks a little about DataView, is the beauty of what DataView has done. They've gone through the raw data, the bronze, the silver, and they've handed you a gold level plate ready to make the transformations necessary. So that's a little bit about database design. If you have any questions, drop them in the chat. I'm also happy to talk to anybody offline. I mentioned the ETL process. And what does that mean? Well, it's a fancy analogy because if it's easy, we just got to throw it into analogy to make ourselves sound smarter. Extract, transform, load. Really all it is and I'm going to read from the screen here now, it's the process by which you go and get source data, transform it into a usable format, and go ahead and load it into its final resting place. If we go ahead and go back to that slide we talked about, an ETL occurs twice. It occurs when you extract the data from the raw data, so this part, the transformations occur right here and right here, but then we also load it. So transformation occurs here, there's a transformation here, but then we load it into our analytics database, and then it's the ability to be served up to our specific BI tools. So all an ETL process is by the way we go ahead and transform all of this data. There are a bunch of different tools that help you. As I mentioned, depending on what database you go with, things may all of a sudden be built in. If you go ahead and decide you want scripting, well, Python can be the solution that you use to make your transformations. That's my preferred scripting language. I've used Rust before. I'm not as familiar with C++ or C#. So if that's your primary script, and I wouldn't call that scripting per se, if that's your primary application development tool, first off, great for you. They're extremely hard languages to use. But there are thousands of tools and little packages that people have created that go ahead and help you. A package that Sandstone both created and uses a lot is Energy Sandbox. It's an open source Python package that we've created that helps specifically manage your ETL process. We've basically created a few different we've made a few different endpoints for some of your classic oil and gas endpoints to help kind of take that data, do some of the transformations automatically so that it can be served up to your database. Basically, it takes and goes from raw to silver in one swoop, so that all you have to do is go from silver to gold. So happy to show people afterwards. If you have any questions on that package, you can actually just pip install it right now. We'll put the link to that in the bio there. But there's thousands of tools that you can use and thousands of open source products. It's one of the beautiful parts about development and the fact that most things are open source, and anything good is open source because they got a lot of people using it. So ETL is all talking about just extracting, transforming, and loading your data and how it goes about that process. So let's specifically talk about extraction. And, just like real estate, it's all about location, along with a little bit of timing. So first thing you need to figure out exactly when you're going and trying to extract all of this data is where. Which departments and which softwares am I going to need to connect to? And really, once you figure that out, the question is, okay, what's the access to those underlying databases? Is it just a CSV export? Is there API access? Is there actually direct database access? Do they send me smoke signals? How exactly do I get access to these? And we'll actually walk through here in a second all three of those different kind of the pros and cons to each access point, because that's another question we get asked a lot is, well, if I'm choosing a vendor or I have the ability to, if they've got multiple access points, which one should I use? Well, the answer is doesn't matter. They all have their pros and cons. The final thing you need to think about with these endpoints is the frequency. First off, how often, as we covered in part one, how often do you need your report updated? If you need it updated daily, you better figure out a way to get your data updated daily. And then layering that in, as I sort of kind of, alluded to, how often do these data sources update? Is it daily, weekly, or monthly? And again, this is going to impact your ETL requirements, specifically from the stuff we talked about in part one. So location, and understanding the frequency of when these data sources update. It's critical because, especially if you're using a cloud database, if you're just updating it 5 times, if you're updating it 5 times a day, but your end data points are only updating once, you're using a lot of power and a lot of usage that, if you're getting charged on a usage basis, going back to what Paul talked about, you're incurring a lot of different tech debt. So understanding the endpoints. I think it's important to go through, I guess, Paul, do you have anything to talk about when it comes to some of these endpoints? We take that as a no. It's fine.
No, yeah, I was just thinking of, no is the short answer.
Cool. So as I mentioned, some of those common extraction techniques, you've got flat file, you've got API access, and you've got what we kind of call direct access, which is basically access to the underlying database. All of them have pros and cons. We'll start with the most easiest one people come across is a CSV export. There are some pros to a CSV export. I ain't opposed to a good CSV export. One of them is anybody can access this. It's pretty easy to click a button and get a CSV export, and it gives you an ability to get your data quickly and show a potential solution. If all your data is just in that one spot, you can very easily just get it out and say, create a pivot table with it, create a pivot chart with that, however you want. Problem with CSV exports is a lot of the times it's still siloed until you load it into your database, which then can play around with all of your other data sources. And unless Excel is your database, it can be difficult to load because you've still got it just on a hard drive somewhere, whether it's on your computer, whether it's in some virtual machine you're running. There's also like no version control. And as we get into building and database design, understanding the frequency also allows you to, from a data quality side, I mean, if you're just pulling and just, what a lot of companies do and a lot of people decide to do is, I'm just going to load my data. I'm going to load just a new copy of my data every single time and just make sure I'm accessing the most recent copy of it. Well, you better have good version control if you're going to do that. And while that might be easy on the extraction side, the transform side, you might find yourself a little bit of an issue. So there, with CSV exports, it can be hard to embed actual version control, and governance can be really tough. So yes, CSV exports, people like them because you can, boom, get them done, but they can lead to a lot of downstream issues. The next is API access. And some people love API access. Some people hate API access. I kind of fall in the middle where there's a time and a place for an API, but it can also be difficult for a variety of reasons. So why is API access cool? Well, it's real time. You can go ping that API. You can hit it as many times as you want. You can write a for loop on a Python and hit that thing 20 times in a row and just keep getting data, especially if you have real-time data, like you're pinging a SCADA set, or you're trying to you're tapping into some frac data as it's coming in from the field. You may want to be able to just hit that as many times as you want. In that case, API access is great. You can also generally vary the query size. They usually have parameters inside that API that allow you to kind of increase or decrease how big of a scope you want, whether you want the last 10 days of data, the last 40 days of data, or some other set that you need. The other, it can be a little bit easier to version control because within your ETL process, you can kind of script in there. Say if you're using Energy Sandbox, for example, you can very easily script in there exactly when it was pulled so that you kind of have an idea of what's like the most recent data. And generally, it's pretty easy to integrate with third-party tools. Again, if you're using an API, generally you're writing your own scripts. There are things like Energy Sandbox. There are other third-party tools, whether open source or proprietary, that you can use that can actually go ahead and make that integration with your data set a lot easier. The next is, on the con side, though, API accesses are they can be very complex from a schema standpoint. I don't know if you're in the crowd and you're a little bit of a developer, anytime I get a new API or I'm looking at diving into an API, I'm prepared for the worst in terms of I don't know how this thing is structured, where my actual source data is going to be. Generally, whoever built the API didn't actually build the database, because you think about it, an API is just an access point to a database. So all they've done is built a interaction with their source database. So sometimes they may or may not have called variables the same. Things might be structured differently. So generally, you get into it and you realize all APIs have different schema. It's not the same from API to API. It's all within this JSON format, but specifically understanding how that schema is laid out can be difficult. And this is for every company besides W Energy and their joint product, which has great documentation. Most APIs have pretty average to poor documentation, and that can be a hard part because you, as a new user to an API, have zero idea how that API is laid out, and it can take a lot of trial and error just to figure out where the data that you need actually lives. They're also non-visual, so if you're new to development or you're just now dabbling in it a little bit and you want to play with a little Python and go and pull some data, it can be hard to visualize an API until you play around with it a lot more. I still struggle with that as well, and sometimes there's no clear hierarchy, and that usually falls under kind of the poor documentation standpoint. Direct access. So this is when a company gives you access to an underlying database. It could be the actual source database, could be an actual silver or gold level database, as we'll cover when Casey talks a little bit about data view. But there are some advantages to this. One, it's pretty easily accessible. If all you need to do is access that specific source, it's pretty easy to layer a BI tool over it. And it's also very easily to integrate a database with another database. It's a merge function. Generally, version control, it's automatically taken care of. And from an internal standpoint at your company, there's little to no support that's needed. You don't need a third party like Paul and me. You don't need internal staff members. It's boom. The database is maintained by whoever that vendor is, and that support kind of falls on them. The cons of this, though, is there's not much you can do outside of the parameters of how they've set it up. You're pretty much limited by the application refresh period. Let's say you're working with a reserves database that only has the ability to update once a week, but you know that your internal team is going through an A&D process, and your manager wants to see, hey, I need to see exactly how the new type curves that are getting built for this A&D process. Well, it's hard to serve that if they don't update until the end of the week. No management's going to say, yeah, sure, we'll just wait till next week to see if that deal's good or not. No. You're going to have to figure out how to get that done right now. And depending on what, whether this database is a, bronze, silver, or gold level, you may or may not need to actually make further transformations, which can make the ingestion process to your BI tool burdensome. As I say there, it could not, it generally isn't analytics ready. To get back to W, it's one of the great things that W does with their data view product. It understands this process intimately and serves you up an analytics ready database, or that gold level database, which is absolutely awesome. And so we've now gone through the extraction, the transformation the extraction process. Let's look a little bit about the transform process. This is, again, just how do we, now that we've got the data, extracted and ready to be used, how do we modify it and update this raw data so that it can meet our reporting requirements? As I mentioned, generally there's a scripting language that's used to perform these tasks. You've got Python, C++, Rust, Node. Node is, it's growing on me a little bit, but then there are other tools. Databricks has their own ETL or transform process built in. There are things like Azure Data Factory, which can do a lot of this stuff for you. You can be a little bit more hands off. And as I mentioned, this can take place before or after loading into a database. If you're, I've built databases this way. I've seen people build databases this way, where the transformation process actually takes place outside of the database and is basically they skip the bronze level and go straight to silver because a transformation process has taken place after the extraction. So they go ahead and they make an API call, they sync up to the database, and then they manipulate that data, within the scripts or within, outside of the database before loading. All can work. It just comes back to, again, one, your skill set, two, what you prefer, and two, some of the data government stuff. So understanding exactly where that transform process takes place can be critical. And then finally, it's the loading. And this just brings it into the final resting place. So once you've got data that's ready for what we would call business level intelligence, now it can be easily served to your BI tool. And that's what, again, the end goal of what we're trying to get here is we need to get data in a way that makes it easy for us to actually do business intelligence. That's why we're here. We're not here to become data engineers per se. We're here so that we can do our jobs. At a previous employer, sometimes I felt like I had a side gig, which was as a data engineer. It's like, well, I also have a day job here, which is, financial analyst or, production analyst, but I'm not necessarily here to build databases. So that's the end goal. And all of this is leading up to, again, building that report and the BI tool. So it would be remiss if we didn't talk a little bit about the BI tool, because the most common question I get is Power BI versus Spotfire. And we talk a little bit about Excel. Nobody really asks about Tableau, so we're going to leave that off. But the big debate in the oil and gas business is Power BI versus Spotfire. Up front, there's no right or wrong answer. It's really what your preference is. And to be honest, most deployments I've seen end up using a combination of both. Okay. There are a few things to consider. One, what database are you going with? Two, how intimate is your company using ArcGIS? And how do you want to distribute these reports? And then also a cost. And we're going to actually walk through, just like we did API access, kind of the pros and cons of both. But Paul, is there anything I'm missing when it comes to BI tools? What have you seen kind of in your experience?
And you're thinking of just like how it's been used, or help me frame your question more.
Is there anything to consider when figuring out a BI tool? Again, the answer can be not.
Yeah. One thing I've seen, this also kind of just goes with, technology as well, is there comes maybe it's like the new greatest thing, or like, hey, this is like really easy to utilize. There's also some like Python type scripts or other ways to like visualize data, but again, kind of keeping it, Power BI, Spotfire.
We love Plotly. Plotly's another good one.
Yeah. But it's just simply to say, like, what sort of level of effort does it take to learn or understand or manipulate data? Mike's had experiences in meetings where, executives or the alike will say, hey, like, well, great, just like tweak this one thing. And it's like, hey, that's going to take like, a day to do that, right? That's part of the reason why it's imperative to have a really clean, precise, just organized database, so that way you can kind of manipulate and move things.
Yep.
And again, it's to say, certainly there's an initial cost with some of these tools. Power BI is also typically in the Microsoft stack, although to my understanding, it's a little bit more. But what is going to be the best thing to really like go all in on? I've just seen companies that have some dashboards with one and then some with the other, and it just creates a challenging work environment. I'll put it that way, right? So the best ability you have to really dedicate to something, have your database flow through that, and stick with that is going to be the best. Because then again, you can scale. There's learning, training, resources with it. You can then hire individuals, educate them. You can become more familiar with it, etc. So again, just be aware of the implications of your decisions and not necessarily just make the decisions.
Yeah, absolutely. So with that, Power BI, what's it good at? As Paul mentioned, it's a Microsoft product, which means great Office 365 integration, spreadsheets. You got spreadsheets, you've got SQL Server, anything within the Microsoft ecosystem, it plays really, really well with. It's also fairly IT friendly. If you're using an external IT team, they generally like Power BI because they're Microsoft trained. 99.9% of oil and gas companies are on the Microsoft ecosystem. I'll be honest, I've yet to come across somebody who uses Google Suite or, Google Analytics, Google Drive or anything of like the Google suite of products within the oil and gas business, because it's much more of an enterprise style business. So can be generally that Power BI is a lot easier on the IT. It's low cost. You can literally download it for free. And if you want to start sharing reports with other people, it's like $20 a user. And can go up to, 40, 50, $60 a month if you need an analytics, and you need analytics stuff. You also can leverage things like Power Query. Now, again, that's a whole nother language to learn, but can be very helpful, especially when you need to make entry level changes. And it's also pretty out of the box. Like you can just download it. If you don't have Power BI on your desktop right now, you can literally just go to your Microsoft store, download it, and get going literally right now. That time to value is 0. On the con side, there's not great mapping capability. And one of the reasons why you see both Spotfire and Power BI deployed within companies is the fact that mapping is critical. If you work in production or you work in operations, everything starts with a map. Every CEO loves to see their maps and likes to be able to drill down into those maps. So if you're a map focused or you're an ArcGIS heavy company, well, Power BI is not necessarily going to play as well. They've tried to go down that road, but it's not as good. There's little non-Office 365 support, meaning if you're using if you're using anything other than like Azure or SQL Server, it can be a little bit difficult to kind of not make the connection. But again, you're going to have no support from an Office 365 standpoint. And again, a lot of the times you're going to need to learn DAX or Power Query. DAX is kind of the Power BI query language, much like Excel has their little formulas. It's kind of the same way with Power BI. They call it DAX, and Power Query is a little bit different in there. So on the Spotfire side, as I mentioned, if you're a map heavy company or you have a really great ArcGIS database that is used by everybody, management likes to start with a map. Generally, that's where we see companies start with Spotfire. And then second, there's actually easier data manipulation. Spotfire has done a really good job of allowing you to do the data transformations to get from silver to gold level databases within their application themselves. The scripting language behind the scenes, they've done a really, really good job of doing that. They've been around the game long. Power BI is a little bit of a newer platform relative to Spotfire. So as always, Microsoft, waits until the market is mature, rolls out their product for cheaper. We saw that with Teams during COVID. They did the same with Power BI in an attempt to hang up with Tibco. One of the reasons why we don't see you may not want to go with Spotfire is it can generally have a higher upfront cost. Licenses can cost in the low 5 figures. And generally, if you're using if you have a large database that's behind the scenes, you're going to have to set up Spotfire server, which could be new for your IT team to implement if they're not necessarily familiar with it. Again, it's also not within that Office 365 ecosystem, which can give it difficulty when it comes to, again, your IT team it's a whole nother software stack that they have to maintain and develop. Unless, if you're at a really small company, maybe you can get around it, but it's definitely not within that Microsoft 365 ecosystem. And just because of all of that, you generally can see a little bit longer time to value. I do see a quote here. Biggest complaint we got about Power BI from finance people is they cannot download the finance reporting view as it looks to Excel. When you download, it becomes raw data again. Yes, that is true. They've done a good job of, if you're in the server, if you're in like the viewing mode, like you're on the Power BI application, like online, like app.powerbi.com, if you're a power user, there they've done a good job of allowing you to export it. But yes, if you're just using their desktop application, it can be difficult to export, and it just gives you the raw data again. So that's another great call out, Paula, for, if you're trying to get data out of Power BI. At the end of the day, nobody trusts reports. Everybody wants to tie their own data out, especially accountants. They're going to want to see it in the way that it gets extracted to. So what's a recommendation here? Well, I'm not going to give you a recommendation because I don't know your specific stack or how you like to go about. What I do know is that there's no one size that fits all. Definitely, there's no specific answer. I would say go find a great resource that can help you fully understand what your needs are and can design a solution specifically to yourself. Paul and I have a personal favorite. We love ourselves a good SQL Server. We love using Energy Sandbox, pip install Energy Sandbox, and we're Power BI folks, if only because we like everything in the Microsoft ecosystem. One of the reasons I love that stack is it plays very, very nicely and can integrate specifically with DataView, which is Casey here. I see her camera off and mute. I hope she's here. Yes, she's here.
I'm here. Yes, I am.
Cool. Well, I've kind of gone through and done a lot. I want to turn it over to you for a little bit. I've teased a little bit about DataView, but I want to kind of turn it over to you and kind of preview what we're going to actually be doing on Tuesday and using this tool.
Okay, awesome. Yeah, so to talk a little bit more about what DataView is, what it's capable of, and why W chose to focus on a product like DataView, we really we like to focus on from the field to finance. So everything from operations, AFEs, budgets, actuals, your production accounting, the data that's coming in from the field, and then of course your back office accounting. W supports all of that. Now, what we saw in the market, what we saw was a huge need that we were hearing from customers over and over again, was that they didn't have any way to get all of their data in one place. And they also wanted access to that data. So we weren't just going to get in the report customization game where we were just building reports, because what we found was that everybody likes the canned reports almost. They liked the canned reports until they needed one specific thing to change. And then there was this need to update that constantly. And then we would get in this cycle where we would have to update and maintain those reports in perpetuity. So what we did instead was we gave everybody access to their data. And I really love the way that when we roll this out to our customers, two things. I really love how quickly they're able to build reports. They can get in there, start building immediately using the tool of their choice. And then the other thing that I've really seen is just that they're using and consuming data in ways that we didn't expect. So they're able to create and solve problems on their own that we didn't even know that they had. So they're creating dashboards, they're creating exceptions reports, they're creating traditional reports, and it's just really taken off in a way that's been fun to watch people use and interact with the W platform. The way DataView works, it sits on top of the data of the W applications, and we've taken all of the tables and normalized them. So we've put them into a reporting structure that makes sense for an end user. So it's not.
If we're going, but not to cut in, but if we go back to the presentation, we talk about medallion architecture. They've gone from silver to gold and served it to you on a platter.
I love that. Yes. That's pretty much exactly what we did. We took all those tables, we normalized them, so you don't have to understand the relationships between those tables. You don't have to be an architect to understand how to build a report, but we understand that you do know your data and you know what it should do and you know what information you want out of the system. So we're giving it to you to get it. It's really been something that people have picked up on quickly and they're able to start using pretty fast. We do have a team at W who helps with this data model and documentation, builds tutorials, and will show you how to do this and work with you and work with your team to get you to that point. And then you can take advantage of whatever additional tools you may have in your business. So we understand that W is going to serve our purposes in this market. There's also going to be other tools that we integrate with, and we want you to be able to see and use all of your data in one place to get a complete picture of the health of your business.
Yeah, no,
So
absolutely. It's a really great tool, and a really great, benefit to, hey, I as Casey mentioned, I know what my data should look like. I'm if you're in finance, you're in your ERP every day. You know what it should look like, or you not know what it should look like, but you know where it is. The question is, how do I go about doing it? And there's all this different stuff. We're going to spend, next Tuesday, we're kind of actually going to get our hands dirty a little bit and see how some of these reports are built from the ground up. And hopefully you can start seeing in your mind, oh, wow, this is how I could use this to build, think about anything. And one of the biggest things, I know one of the first things that I used when I got my hands on DataView was a production variance report. And what I mean is I want to know gross volumes versus net volumes, but then versus sales. If I was at a smaller company, I need to know exactly, are we actually selling all the barrels we are producing? And if we're not, what's that slippage? Especially if you're handing out distributions on a monthly basis, you want to be able to know, hey, are we going to, what's our future forecasted actual, oil price or oil sales going to look like? So really awesome stuff. I'm super excited to get that done. Is there anything else, Casey? Anything else I'm forgetting here?
I mean, I'm just really excited for everybody to get a chance in session 3 to actually see one of these reports being built. And then also, getting a chance to see what DataView can do. And like actually seeing the output of some of the work that's been going on behind the scenes. Also, I want to mention that we are sharing 2 handouts, and we'd love it if you guys would go download those, take a look at them. We have an overview of DataView, and we also have a link to our DataView blog. We'd love it if you'd read that. Send us any questions. There's several of us on this call that would love to talk to you or answer any questions you have about DataView. But yeah, let's get our hands dirty. Let's build a report. I'm excited about it.
Absolutely. If you have any questions, you can email for W. You can email marketing@wenergysoftware.com. You can check him out online. You can connect with both Paul, Casey, and myself on LinkedIn. But for everybody, we're going to go ahead and let you get out of here. Appreciate everybody sticking through this. And we're just excited. Stay tuned. Really looking forward to see everybody in part 3. But with that, guys, we'll let you get out of here.
Bye, everybody. Thank you.
Awesome. Thanks, everyone.